This video is a part of my full digital guitar pedal building course. In this episode, I'll teach you how to make a drill schematic for Tata Electronics so that we won't have to physically drill our enclosure ourselves and can have them do it for us. This course is also sponsored by PCBWay, a quick, cheap, and well-made solution for getting PCBs custom manufactured. I'll show you how to order through them later in the course, so stay tuned for that. Alright, so to start, we are going to make our drill template for the Tata Electronics site, which pretty much means that we're going to decide what layout you would like for your pedal. I'll go over some limitations and things to keep in mind for that, but first we get to pick out which enclosure you would like to use. So here I am just on the Tata Electronics website, and we're going to go down to hardware and then enclosures. So here you can see there are all these different sizes of enclosures that you have to pick from. They range in price, and I think they're all pretty much the same material. They're all just aluminum. And then we come down here and you can see you can get them in just a solid color. So definitely take some time to scroll through here, but I would be cautious because some of the sizes for these in the photos look very deceptive. So definitely go in and check the actual dimensions. Like for example, you can see here is the 125B, which is the one that I ended up using, and then the 1590B. And you can see in these two photos, they kind of look the same size. If anything, this one looks like it's maybe a bit wider. But then if we come over here to my desk, this is a 225B and this right here is a 1590B. And as you might be able to see, the 125B is quite a bit larger, and more specifically, it is much taller. So you really want to be careful when you're looking at these, especially with height, because with our Daisy, it does take a good amount of height. So something like this is quite easy to fit everything in with the knobs taking up all that space in there, and then the Daisy. So something like this, you would have to design it much more smart to be able to fit everything in there. So that's kind of why I choose the 125B, is so it can fit the Daisy really nice, and it just has a little more surface area than the 1590B. So if you're trying to do something with like 4 or more knobs, or maybe some knobs and some switches, or 2 foot switches, then you'll definitely want something bigger than something like the 1590B. But this is a great option if you're better at fitting everything in there and you want maybe like 2 to 3 knobs can fit really nicely in here, and then it will kind of give that really nice sort of boutique, because the small pedal is quite nice. And then they do have much larger ones if you're wanting to do some sort of really big multi-effects thing with a ton of knobs, then that's super doable. But once you find out the enclosure that you would like to use, definitely just type it in here to search it so that you don't end up getting one with all the different colors if you don't want that. So like here's just the base 125B, which comes in about $5.50, and then if you want, you can go and look at the colors and stuff. It only adds an extra 50 cents for powder coatings here, but also to note, like if you just want color on the top, that is UV printing and the graphic stuff will do. So this is just if you want obviously just the whole pedal to be a different thing, and then we put the graphics on top of that. But this has nothing like directly with the graphics will do. I mean, you'll have to do stuff with colors based on the enclosure color that you use, but it's not too big of a worry, and you can kind of worry about the color after we make your graphic and everything, because you won't really be ordering any of these parts until you have the design with it too. So once you have the enclosure you would like to use picked out, next is just to obviously think up the amount of knobs, switches, and everything that you would like to use. You can either just sort of draw this out. Maybe you're a graphic designer and you sort of do that first, or that's how you think, or maybe you just have a pedal of your own that you would like to replicate. Any of that works. Just sort of think that up, and then we're going to head to the Tata Drill tool. So you can search Tata Drill, and then they have this really nice place where we can make these drill templates here. So it'll show up with the enclosure types here, so you can just pick whichever enclosure you would going with. And here's maybe also a good place to see all those sizes just quickly. You can see which ones are the biggest nicely. So this is just so we can give Tata a little document saying where we want all of our holes to drill. So we don't really have to use any tools to drill stuff. If you do have like some sort of drill press or something, then obviously you could just do this on your own. But say you wanted to order 50 of these or sell anything more than that, or maybe just make 10 for friends or something, this would save a lot of time, and it's really not that much money. We can see in Tata, you can search drill here, and here you can see all the drill services. You will have to sort of add this to cart in addition to the enclosure. I'll show you all that later though, so you don't have to worry about that yet, but you can see they're all the same price, so it doesn't really matter if you're having a big or small. This will cover up to 40 drill points, which is a ton. So you're probably not hitting that for your first pedal or anything. And then you can see it also gets much cheaper the more you add. So it is more than half off if you get 50 plus, if you were to actually sell some. So back to the drill tool. The next thing you'll need to do is figure out what sizes the diameters of the components are, quite obviously. This is also pretty simple, but can be somewhat like nerve-wracking if you don't have the part sitting in front of you, because obviously if you got the holes wrong and they are too small or maybe way too big, then that whole enclosure you will need to rethink after you have already ordered it. But luckily it's really not that hard to make sure your values are good with plenty of clearance for them to fit. So there is a couple ways to do this. One is if you don't already have your parts on Tata or whatever you're ordering your parts. Like here is where I think my knobs are from. Yeah, these are the knobs I use. So you can see here this knob has a shaft diameter of 6 millimeters, which you might think that, okay, that's our size, 6 millimeters, but there's a few definitely wrong things about that. One is that you obviously need to add an extra bit of space. And then in the case of this knob, the shaft is this top part that you actually turn, but you'll see this bottom part with where you screw the nuts and washer onto there, that is clearly sticking out much more. So 6 is not going to cut it at all. So 6, even with a little bit of clearance, will probably not be able to fit this extra part there. But you can see that right below here, we have mounting hole, 7.5 millimeters. So that is probably the answer. We can come in here to the data sheet and see a little better everything. So yeah, they have mounting hole detail and they just very nicely tell us this means diameter. So we have a 7.5 diameter, and you can confirm that. Like here we see this washer, which we know fits over top of it, and that has an inner diameter of 7.1. So clearly this 7.5 is giving us that clearance already of about 0.4, so that should work great. There are definitely times where it just won't nicely say mounting hole. For example, this is the foot switch that I use. And by the way, all of the SKU numbers for all of these Tata parts, I'm going to put in the sort of GitHub documentation of this whole course in the description. So don't worry about having to type this in and find them all yourself. You can go there and they'll all be linked. But here you can see there's literally not a single thing talking about the diameter of anything. But if we click the data sheet, you can see they have this very minimal photo just giving some basic measurements. And then right here, we can see they show the inner one is the diameter 8.5. And then we have this M12X1. That's just referring to the actual like bolt or screw. So the amount, so like the thread length here is 1 millimeter and then the diameter is 12 millimeters. So this would be nice to know what type of nuts you would need to put over it. But for our case, we can probably just assume that 12 millimeters would be okay, and you could add a little bit on top of that. I know with this foot switch, I think I do 12 millimeters because I just measured it after I bought it, which I can show you in a second. But it's kind of not as nice, obviously, as just seeing the mounting holes, but it should be fine. I'll talk about sort of the recommended amount of clearance to add based on what you might see in data sheets or measuring it yourself, which I will show you right now. All right, so here I am with all of the parts that I just showed you, the pot and the foot switch, and here's a jack that I use, and calipers. This is a pretty must-buy tool if you're going to do stuff like this. But yeah, you can just really nicely measure. This one's a digital caliper. It's only like 10 bucks or something. And this would be really handy because I can take something like this knob, put it right here, and then I typically add about 0.4 to the value here. So this knob, I'd probably go and do 7.2, which adds up with the, I think 7.5 that Tata said it was. And then you can see if I were to measure this top, it is about 6, just like it said on the data sheet. Same here, I think we said 12 for this one. So if I measure, you can see we're just about 11.6, a little more, a little less. So that 12 makes perfect sense. So coming back to the drill tool, make sure you have written down or know those numbers of all the diameters. And then here we can just go about placing everything. A few things to note with sizing. Say you were to try and make like a 6 knob pedal or something, then you definitely want to know the measurement of the overall part. Like say you wanted 6 knobs, then here with this knob, you would want to really know that like this whole diameter is 16.9. So you want to make sure that when you place it near the edge, you don't totally push it over the edge there. And also keep in mind that in the corners of all of these boxes are little screw holes. So I wouldn't shove anything like directly in the corner, especially when we are fitting the PCB in there. We're not going to have the PCB fully just stretch out to be the size of this perfectly. You know, you could have a little cutout for them in the PCB, but I just wouldn't go around throwing things in the absolute edges. But if you're just looking to do a 3 or 4 knob thing, then should be pretty kind of intuitive of just placing them nice and even, not too far back or close to the edge. Teta is a little bit strange. As you can see here, the 0, position is in the center, so everything we do is just going to be offsetting that from the center. So a positive X will put you to the right and negative to the left, and then same thing for Y. Positive will be up and negative will be down. Here you can pick what side you would like to put everything on. All of the sides except the lid are included in the base drill template, like that initial cost. But if you do, for some reason, want to add holes on the lid, then you will need to buy a separate service. Teta also somewhat recently in the past few years added these awesome abilities to do lines and shapes, which honestly is pretty huge. Like if you want to do something like a little screen cutout or something, then you can really easily add that, or some sort of cooler LED pattern or something. You can really easily do that now, and it'll just be included in that base drill template. So just as an example, here is the pedal that I ended up making. I will put a link to this template in the GitHub so you don't have to recreate it if you're making this pedal. But yeah, you can pretty much just see everything we talked about, like 7.2 diameter is what I ended up doing, 12, and then just sort of spacing them out nice and symmetrically, which having it be symmetrical isn't like required. It might make your life a little bit easier when it comes to making the actual PCB, but not really enough that you should totally make the design around that. So the main big design limitation when it comes to dreaming up your pedal is the actual daisy. We can see here the daisy is 51 millimeters long and 18 millimeters wide. So you need to make sure that when you are spacing out your knobs that it accounts for that. For the most part, if you're just trying to do like 1 to 4 knobs, I would say you can just think up your pedal and then imagine where the daisy goes afterwards or when it comes to the PCB, and then you can always come back and sort of move things around. But if you're trying to do like 6 or more knobs, if it is this enclosure, obviously if you have one of the big ones, then it doesn't matter. But if you're trying to do like 6 knobs, then you're gonna have to think that out. Like if you were trying to place them in this cool, like a regular design, that's gonna be a little bit tough. If you want them to just be symmetrical, like here, for example, the daisy is horizontal. I'll show you actually the insides of the pedal in a second so you can sort of see what the final product's gonna look like when you're imagining your knob layout. But yeah, here it is horizontal. So I basically need to make sure that there is those 18 millimeters in between each hole. But the thing is, the holes aren't exactly where the pins in the PCB are. As you can see with this knob, the actual center of where the hole is about 16.5 millimeters from the pins. So what that means is that the hole might be here, but the actual PCB is here. At the end of the day, you can still sort of think of it as the distances between these two, because obviously just in this case, the PCB actually starts or sort of ends around here. And then the daisy is going to be sitting probably right here. But yeah, you need to make sure that you remember that and have that in mind. Like in this case, I could not put a knob right here because then those pins would most likely be right over the daisy, which also can be okay since the daisy will have these headers, meaning it is sort of raised up. You can actually put and solder things in the middle of the daisy, but you would need to make sure that it's not directly stepping over the pins, and it just adds a little bit of complexity if you do have all of these pots and components in the middle of the daisy. But yeah, that's pretty much all in terms of the drill schematic. I will say there's a high chance, especially if this is your first time doing this, that you will be sort of changing this as we make the graphic and the PCB. So I wouldn't worry too much about it. I would mainly just know how many knobs you want or switches or LEDs or anything. And to just make sure you know which parts you're going to use. You don't have to have like all the specifications written out, but you will be needing to refer to them quite a bit as we make the graphic and especially the PCB. All right, Sam from the future here. I realized after filming this that I forgot to mention anything about the audio jacks up top here. And it's pretty simple, but there are just some things you want to remember. First off, you obviously have all your different sides you could place them. The typical ones are either on the top or on the side, the right as the input and left as the output. For the 125B enclosure, I probably could fit the jacks on the side here. I just kind of like them at the top personally, and I like when they sit sort of cleanly with the DC jack. If you are doing the top, the one main thing you'll need to remember is the screw holes. So if you had something like a 1590B and you wanted to do a setup like this, that's going to be much tighter, and maybe really thick audio jacks like this aren't going to work. The other thing you want to be mindful of are the actual potentiometers that will be below your audio jack, so you can see the potentiometers under there. And to be clear of that, I just didn't put them center. You know, you have them up a bit, which then you would just want to check the data sheet for whatever jack you use. They're much smaller jacks than the ones I have here. These ones are just pretty cheap on Tata. But yeah, like everything else, you're going to want to cross-reference with the data sheet and the measurements and then your actual enclosure. Like I said, there's much smaller jacks. So like here is the 1590B pedal, and it's facing this way, so the PCB will be here, and then I actually just put the jacks down here, and these are ones that have a much smaller kind of overall size there, so they can go pretty tight. They could even probably fit nicely in a 1590A, which is a little bit smaller. But yeah, something like this, these would be kind of tight at the top, so I just decided to mount them on the side, which a lot of pedals have them on the side too. Especially if you wanted to do like PCB mounted jacks. They're pretty easy to do. You just got to be kind of mindful and make sure you buy ones that you can slot in flush, and then we'll kind of put the screw thing from the outside. I don't have any on me right now, but there's ones like this one right here, which protrudes out, and this wouldn't be good because if I were to unscrew this, if I were to have this on the edge of a PCB, and then obviously if I slot it in, it'll just hit it there, and that won't really work. So make sure to get ones that do. But yeah, if you're using like the 125B and you want them at the top, these values work great. So you can just copy these B-side ones. And if you want them to be on the sides, just be mindful of your foot switch, but you can always put the foot switch kind of parallel with the jack so that it won't interfere with each other, and it should be all right. But yeah, that's about it for the drill tool. Whoa, you're almost halfway done the course. Congratulations. Hopefully by now you have a nice drill schematic, so going forward we can reference it when we make our PCB. In the next episode, I'll teach you the basics of KiCad, which is a nice software for designing PCBs. The playlist for the full build is linked below. I'll see you there.